In today's session, we are going to discuss free fall. When we talk about free fall, few questions come to our mind. The most common ones are, what is free fall? What do we actually mean by acceleration due to gravity? And how do we calculate free fall? To get answers to all these questions, we have to understand first what free fall really means. Okay? As there is a saying that all that goes up comes down. Now I want you to do something. You have to imagine that you all are holding a ball. Ready? And now you throw the ball up. What did you observe? Yes, the ball is accelerating towards the ground. How do we define free fall? Free fall is the downward movement of an object under the influence of gravity. According to Newtonian physics, a free fall is the motion of any object where gravity is the only force acting on it. But what about the ball that I just dropped? Was gravity the only force that acted on it? In reality, there are two forces that acted on this ball. One, the force of gravity that pulled the ball down, and second, the air resistance, that is the upward force exerted by the air that tried to push the ball up. When the object is in free fall, there is no change in direction, but velocity certainly changes. As we know, any change in velocity is acceleration. Acceleration happens due to the pull of gravity and it is denoted by letter small g. Gravity varies depending on location and altitude on Earth. But the average acceleration due to gravity on Earth is 9.8 meter per second squared. And the SI unit of g is the same as acceleration, that is meter per second squared. Let's do an activity. In this activity, a ball and a piece of paper are dropped from the same height. As the objects are released, they start falling towards the ground due to gravitational pull of the earth. The gravitational force exerted by the earth on both objects is equal. However, they do not reach the ground at the same time. What do you think this reason for this is? Yes, the reason the paper touches the floor later is because of air resistance. In the activity, you can see the air offers much more resistance to the falling paper compared to the ball. Therefore, the paper falls down slowly. However, if the same activity is performed in a vacuum, they both will fall at the same rate at the same time. Let's watch a video clip from NASA Space Power Facility of objects being dropped in vacuum. As you saw, in vacuum, the objects fall at the same rate, irrespective of their mass, as there is no air resistance. But the question is, how do we calculate the free fall of an object falling from a certain height where it also faces air resistance? Well, to calculate free fall, at school level, we have to assume that our ball is falling in a straight line as in a vacuum, where there is no air resistance, just like you saw in the NASA video. When any object is dropped, the initial velocity is 0. Once the object is in motion, it is said to be in free fall. The motion in this situation has a constant acceleration, that is g, as it falls towards the ground. The equations that are used for free fall are known as the kinematic equations. If you are wondering what kinematic equations are, they are equations that describe the motion of an object with constant acceleration. The equation that you will generally use are, number 1, Vf, that's the final velocity, equal to Vi, initial velocity, and At. Equation number 2, x, or the distance or height, equals to half Vi plus Vf multiplied by t, which is time. And number 3, x is equal to initial velocity Vi t plus half a t square. A is the acceleration due to gravity and t is time. In free fall, the initial velocity, denoted by letter v1, is always 0. Acceleration due to gravity, a, will be g, and the value of g we already know is 9.8 meter per second squared. G is basically the gravitational field of the earth working on the body. What this means here is that this much force is working on the ball to pull it down. Generally, two types of questions are asked. Number 1, what will be the velocity of an object at a particular point in a time after it has been dropped from a certain height? And number 2, what will be the distance covered by the object after falling? Let me give you a couple of examples. Problem 1. It says a ball is dropped from the top of a building. The time taken to hit the ground is 4 seconds. So here you have to answer two things. Number 1, they are asking you, what do you think the height of the building is, assuming the value of g is 9.8 meter per second squared. And the second thing they are asking is, what will be the final velocity? Okay, now that you have read the question, let's solve it. What are the information which is given here? They have given you the time, which is 4 seconds. They have also mentioned the initial velocity, and as you know, the initial velocity is always 0. That is 0 meter per second. And the g, that is the acceleration due to gravity, which is constant, as you already know, that is 9.8 meter per second square. And we have already talked about our kinematic equations. There are 3 equations given. Now the question comes, which equation we have to use to solve this? Now equation 1 and equation 2 needs final velocity, which is not given in our information here. So we cannot use the first one, we cannot use the second one, but third one we definitely can use it. Why? Because they have given the initial velocity, they have given the time, and we already know what the acceleration due to gravity is. Okay, in free fall, as we know, that any object which we drop from a certain height, say from a building. So if this is the building, and suppose if this is the ball, the fall will be always in a downward direction. And the distance traveled by the ball from the top to the bottom is equal to the height of the building. So we can denote it with letter h. That is the distance covered by the ball when it's thrown from a building. Okay, so let's solve it. Equation 3, let's rewrite the equation. Ei, that is initial velocity times time, plus half a t squared. Now all we have to do is plug in the information. So x will be equal to Vi is given, which is always, as you know, it has to be 0. And when any number multiplied by 0 is always 0, so we don't write that. Plus half acceleration value is given, that is 9.8 times time is 4, which is squared. So if we calculate this, this comes to 78.4 meters. So this is the height of the building. So that much distance has been covered by the ball when it's dropped from a particular height. Okay, so we got our first answer, that was the height. Now other thing they are asking is the final velocity. So for final velocity we have to use equation number 1. So let's write it again. Final velocity is equal to initial velocity plus at. So again we just have to plug in the information. So V final velocity will be initial velocity of course 0 plus A value is given 9.8 times T is 4 seconds. So if we calculate this, then Vf will be equal to 39.4 meter per second. So this is our final velocity. So we got our two answers. Height, that much distance the ball covered, and what was the velocity when it came down? That was 39.4. From initial velocity was 0. And now it's time to do the next problem, which will be done by my colleague.
Problem 2. If an object falls from a height of 8 meters, how long will it take for this object to reach the ground? What will be its final velocity? Now that you all have read the question, we will start solving the problem. The given information is up on the board. Height is 8 meters. Initial velocity is 0 meter per second. Acceleration due to gravity is 9.8 meter per second square. In this question, we have to find the time taken by the object to reach the ground, so that's t, and we also have to find the final velocity. The three kinematic equations are up on the board. Let's see which equation can be used to solve this problem. The first equation is final velocity is equal to initial velocity plus at. In this question, we do not have the time as well as the final velocity. So this equation cannot be used. In the second equation, we do not have the final velocity as well as the time taken. So this equation also cannot be used. Now let's look at the third equation. Here we do not have the time t, but the other values we do have. X is the height, okay, the distance. So we have the height. Initial velocity, yes, we have. And a, which is acceleration due to gravity, we do have the value of that. So this will be our equation with which we will solve this problem. Okay, I have written the equation that we have selected to solve this problem. Over here, x is the height. Okay, so I'll put h in brackets over here. We need initial velocity over here. So initial velocity is 0. So any number multiplied by 0 will be 0. Plus a, which is acceleration due to gravity, and t squared. Here we have to find time, that's t. We will rearrange the terms accordingly. So I'll take t out. It will be a square root of 2h upon a. So now we will substitute the terms in this equation. H is 8 upon acceleration due to gravity, that is 9.8. We put in the units as well. Okay, so the final answer, here this meter unit gets cancelled. Okay, the final answer is 1.26 second. So we found out t. We can add the value of t over here. Now we shall move ahead to find the final velocity. So which equation can we use? We can use the first one to find the final velocity, as we have the initial velocity, acceleration due to gravity, and we also found out the time. So I'll write the equation. We can substitute the values. Initial velocity is 0. Acceleration due to gravity is 9.8 and time is 1.26 seconds. Once we do the math, the final answer is 12.3 meter per second, which is the final velocity.
Always remember, when the motion of an object is upwards, the acceleration due to gravity will be negative, that is negative g. Why? Because the direction of the motion is opposite to the pull of gravity. Also, the velocity in the upward direction decreases so that the final velocity becomes 0. So remember this portion. Here is an assignment for you. Now that we have explained you the concept and we have shown you how to solve the problems, we hope that this video will help you to understand the concept of free fall.